Saturn's rings formation and secrets. Among all the breathtaking sights in our solar system, the rings of Saturn stand out as one of the most beautiful and mysterious features ever observed. This giant planet, second only to Jupiter in size, is surrounded by a wide and bright system of rings that has fascinated astronomers for centuries. When Galileo Galilei first observed Saturn through a telescope, he could not fully understand what he was seeing and described it as a planet with strange ears. Over time, scientists realized that these were not solid structures but a complex system of rings made up of countless particles. Even today, Saturn's rings continue to raise important questions about their origin, structure, and long-term future. Saturn is a gas giant composed mainly of hydrogen and helium, which means it does not have a solid surface like Earth. Surrounding this massive planet is a system of rings that appears solid from a distance but is actually made up of billions of individual pieces. These particles range in size from tiny dust grains to large chunks as big as mountains. Most of these particles are made of water ice, which reflects sunlight and gives the rings their bright, shining appearance. This is why Saturn's rings are much more visible than the faint rings found around other planets. One of the biggest mysteries surrounding Saturn's rings is how they formed. For many years, scientists believe that the rings formed at the same time as Saturn, around 4.5 billion years ago. However, newer research suggests that the rings might be much younger, possibly only a few 100 million years old. This has led to several theories about their origin. One widely accepted idea is that the rings were formed when a large moon or comet came too close to Saturn and was torn apart by its strong gravitational forces. This process happens when an object crosses a boundary known as the Roche limit, where the tidal forces of the planet become too strong for the object to hold itself together. Another theory suggests that the rings are made from leftover material that never formed into a moon. In the early solar system, many small particles and objects were constantly colliding and combining to form larger bodies. Some of this material may have remained in orbit around Saturn, unable to come together because of the planet's strong gravity. Over time, this material spread out into the ring system we see today. Saturn's rings are not a single flat structure but are divided into several main sections, including the A ring, B ring, and C ring. Each of these rings has its own unique characteristics, such as differences in thickness, density, and brightness. Between these rings are gaps, the most famous of which is the Cassini division. These gaps are not completely empty but contain fewer particles. Their formation is often linked to the gravitational influence of Saturn's moons, which affect the motion of particles within the rings. The moons of Saturn play a very important role in shaping and maintaining the rings. Some of these moons, known as shepherd moons, orbit near the edges of the rings and use their gravity to keep the particles in place. These moons act like cosmic guides, preventing the rings from spreading out and helping to create sharp boundaries and narrow ringlets. Without these moons, the rings might slowly disperse over time, losing their well-defined structure. One of the most fascinating aspects of Saturn's rings is that they are constantly changing. The particles within the rings are always moving, colliding with one another, and interacting through gravity. These interactions can create waves and ripples within the rings, similar to waves in water. Scientists have observed patterns such as spiral density waves, which are caused by the gravitational pull of nearby moons. These patterns provide valuable information about the forces acting within the ring system and help scientists understand how similar processes might occur elsewhere in the universe. Another important mystery is why Saturn has such a large and bright ring system compared to other planets. While Jupiter, Uranus, and Neptune also have rings, they are much fainter and less noticeable. One reason for Saturn's prominent rings is the high amount of ice in the particles, which reflects sunlight very effectively. Another reason could be the history of collisions in Saturn's system, which may have created a larger amount of debris to form the rings. Space missions have played a major role in uncovering the secrets of Saturn's rings. One of the most important missions was Cassini-Huygens, which studied Saturn and its rings for more than 13 years. This mission provided incredibly detailed images and data, revealing the complexity of the rings in ways never seen before. It showed that the rings are dynamic systems with ongoing processes, rather than static structures. Scientists were able to observe fine details such as small ringlets, temporary features, and changes over time. Despite all these discoveries, many questions remain unanswered. Scientists are still trying to determine the exact age of Saturn's rings and how long they will continue to exist. Some evidence suggests that the rings may gradually disappear over time. Tiny particles are being pulled into Saturn's atmosphere by gravity, a process often referred to as ring rain. Over millions of years, this could cause the rings to fade away, meaning that they may not be a permanent feature of the planet. Saturn's rings are not just beautiful to look at, they also provide a valuable opportunity for scientific study. They act as a natural laboratory where scientists can observe how particles behave under the influence of gravity. By studying the motion and interaction of these particles, scientists can gain insights into the formation of planets, the behavior of disk around stars, and the structure of galaxies. In conclusion, Saturn's rings are one of the most remarkable and mysterious features in our solar system. They are made up of countless particles of ice and rock, arranged in a delicate balance by gravity and motion. Their origin is still debated, with theories suggesting they may have formed from the destruction of a moon or from leftover material in the early solar system. Their structure is shaped by the influence of Saturn's moons, and their future may involve gradual disappearance. Saturn's rings remind us of the beauty and complexity of the universe. They show that even something that appears simple from a distance can be made up of countless interacting parts. As scientists continue to study these rings, they will uncover more secrets that will deepen our understanding of the cosmos and the forces that shape it. If you found this explanation of Saturn's rings formation and secrets interesting and informative, do not forget to like the video and subscribe to the channel for more engaging content about space, science, and the wonders of our universe.